Circle this right here. You have probably not seen this before. This is what I'm calling set builder notation. Anytime the word set is mentioned, you'll see some brackets on the ends, like that. Over here, write down that Z. Usually it's a funny looking Z. It's a little more fancy, maybe italicized. That just means that we're focused only on the integer set. What's the difference between integers and all numbers? What numbers are we leaving out? We're just looking at odds. No, we can still have odd. We can have even, odd. What numbers are we not looking at? Nope, we can have negatives. In fact, underneath this, write down number line. What you would normally see on a number line, -5, -4, -3, 0, 1, 2, 3. That's what we're talking about. So what are we not talking about? Decimals, fractions, everything in between. We generally don't use that set, but if you see a Z showing up, that just means that you're strictly looking at whole numbers and their opposites. This is the letter we normally see. If you see a big R, that stands for real numbers set. Real numbers just mean everything. There's actually imaginary numbers that you'll get to in Algebra 2, or possibly at the end of AFBA, if you do that. But we don't get into those numbers. Those are things like the square roots of negative numbers. They're imaginary. Everything means everything in between and the integers. So this includes all the decimals. This includes all of the fractions. This is what we normally deal with, all numbers. So if you see an R showing up over here, it just means you're considering all the numbers. Put this thing right here. What letter does that look like? E. What that stands for? Element of. And that's all in here. I'm just pulling out the important parts of what is in these sections. You can read through all of this, but it's basically going to say the same thing that I've been saying. Element of. So we're saying the X we're dealing with can be from only integers. If we have an R there, then we're saying that it could be decimals also. What does this really mean? Well, if you look down below, at the number line off in the bottom left. You guys know how to do inequalities. If I'm going to do an inequality of this right here, then it would look like 0 less than or equal to x less than 4. How come I have less than or equal to there? What kind of circle do I have? Closed, right here. Put a little arrow from here to here. We've got an open one right here. That's why this is just a less than symbol. You already know how to do that. If you're writing it in set builder notation, this is how it looks. You might say X, and you have a big line there, and then you show the inequality. It's just another way that a textbook might show it. It also might show it this way. X element of R with a big slash, and then 0 and the 4 and closing it off. Chances are you're going to see it more like this. They'll tell you what set to consider. Is this a solid line in between here? That's solid. That means that you're considering all of the decimals and all the fractions that are in between. So if we're considering those, we should have all the real numbers in between. This is saying look at all the real numbers. This is just a dividing line. The thing to the right of the line tells you exactly what x's you're looking at. So it's the same as this, only we're being a little more specific about what's going on. This is called interval notation. This right here is exactly the same as writing this. Some textbooks do it this way, some textbooks do it this way. Notice, this right here is kind of like a parentheses. What's this kind of like? What do we call that? A bracket. If you're using a bracket, that's like looking at a closed circle. If you're using a parentheses, that's like doing an open circle. It's just another way of writing. So, pop over to here. Let's write these two in both ways. You know that that's an open circle and an open circle. Well, open circles are just parentheses, no brackets. So if I'm going to do this, let's see what's underneath here. It would look like that. This is not a point. This is called interval notation. This is saying, darken this in. Just make it a little bit darker so that you know it's not a point. That is just another way of writing this. You put the 10, you put the -7. Since it's an open circle and an open circle, you put parentheses. This is not a point. It's called interval notation. This one has an open circle and a closed circle. It looks like this. We have a 3 open circle, so we do this. This is a closed circle, so we do a bracket. These are not points, these are interval notations. Have you seen this before? Or is this totally new to you? Are we doing any calculation work here? No, we're not adding, subtracting, or anything. We're just rewriting it in a different way. That is what 60% of what you do this year. It's just learning ways of writing things. You'll actually use this as you move on to AFBA or Algebra 2 or Geometry, wherever you go after this. This year is a lot of tool building. Jump down. Let's see. Turn to the next page. What happens when you don't have a number and it goes on forever? We don't say it goes on forever. What do we say?
Infinite.
Infinite. What's the symbol for infinity?
Sideways 8.
Sideways 8. Here's 2 ways to write it. What does the R mean? All numbers. That includes decimals. If it's a solid line, we're including all of the fractions and all of the decimals. So we want that first. This is just a line separating the set from the specifics. Does this look like x is bigger than -1? It is. Put that x over here. Whatever your variable is, you should get in the habit of putting it to the right of the number line, so that whoever's reading this understands x is all of this stuff. What's that symbol? Infinite. Anytime you have this arrow, you want to use an infinite symbol. This is not a point. This is the same as this right here. Instead of writing it this way, we're writing it this way. It goes from -1. How come I'm using parentheses and not a bracket? Open circle. Open circle goes with that. And for infinity, you always use parentheses. A lot of this is already written down here. I'm not going over every little thing that's on here. To prepare for Monday's little mini test, go back, read through this. It just emphasizes what I've already said usually. This is set builder notation over here. This is called interval notation. Write that down underneath. Set builder notation. And this is interval notation. Tyler, question? Okay. So you tell me what you think set builder and interval notation is going to look like for this. If it's a closed dot, what does that mean? Less than or equal to. So we know less than or equal to is going to appear here. Is this a solid line? So that means that we're including fractions and decimals. So I would expect to see the R again, because that deals with all numbers. And what is that symbol right there? That's a bracket. If it's a closed dot, we should have a bracket. Does this ever end? No, this goes on forever. So what symbol do we want? We want infinity, but is it positive infinity? We want negative infinity. We always use parentheses with the infinities. Why is that a bracket? That's a bracket because it's a closed circle. How would it look in set builder notation? It would look like this. Why is the R there? Because this is solid. If we just had a bunch of dots on the line, then we would probably be doing a Z instead of an R. Yes.
Why does it start on the 2 and not on
Why does it start on what?
the 2?
That's just what's being handed to us. They're saying take this drawing and rewrite it in 2 new ways. So the 2's there. That means I have to have less than or equal to. What is this thing? That's just kind of a separation line between your set and what specific numbers you're dealing with. Let's take a look at 1, 2, and 3. There's a couple new things down here. All right, number 1. Right here, do you see that U? That U stands for union. It just means we're looking at both things at the same time. So if you see 2 separate sections, you're going to see a U in between. What does this mean? Does this mean bracket or parentheses? That's going to be a bracket. What about this one? Bracket. What about that one? That's going to be parentheses. And this, we're going to have a bracket. What numbers do I have? I got a -7 and a -1. I've got a 3 and a 7. The parentheses tell me that 3 is not included. It's open. Let's see what I've got. This looks good. We're going from -7 to -1. It's closed circles. This one's got a closed circle there. It's got open there. So this is okay. But this one is okay also. Both answers are correct. There's 2 different ways of writing the same thing. One uses inequalities. One uses our new interval notation. Because that matches perfect. So there's 4 or 5 different ways you can write down all of these sets. So this one, everything was right. You might have to read through a couple things. All numbers from negative infinity up to and including -4, as well as numbers greater than +1. What does negative infinity look like? Do I put parentheses or brackets with infinity?
Brackets.
Parentheses, always parentheses with infinity.
You said, the last one you did, you put brackets in there.
Because this one up here, this one, because it was numbers, I'm using the brackets or parentheses. For this, always parentheses. If it includes -4, I should have a bracket. It includes it. We want it. Numbers greater than +1. So we want something that includes that. Whoops. Thank you. Parentheses. Does that look like this one right here? That matches up. So that definitely works. Do any of the others work? Greater than +1. That's greater than +1. That's less than or equal to -4. Can I use this one? Let me see. I can't use this one. Why can't I use the middle one? What's different about this and this right here? What's wrong? What's different? Raise your hand. Tell me what looks different between what I wrote and what's in this middle one right here. Great. There's a bracket right here. What do we want? Parentheses. So cross that one out. We can't have that. What's wrong with the first one? The first one is no good either. If it's parentheses, that means 1 is not included. Do we want this to be greater than and equal to? We don't want the or equal to there. We're going to cross that one out. This is the only one that works because we got greater than, which is exactly what is written there. It's not greater than or equal to, it's just greater than. So you're going to have to look at really detailed stuff when you're doing this. There's no calculation involved. You just have to focus and make sure that your greater thans and less thans match up with parentheses. Your brackets are the ones that go with the or equal to. And what does the R mean? What's the R mean? Real numbers means that we're including all of the stuff in between, all the fractions, all of the decimals. Let's do one more. We're just looking at number 3. All numbers from -3 up to and including +7. There's only one of these that works. Out of these 3, which one goes along with that sentence? Which one do you think works? Raise your hand. If you give me an answer, give me a justification. Tell me why it's correct. Only one of those three is right. What's the key word up top that's probably going to help us? What's a key word up here that's important? Yeah. Including. Circle that. Let's circle that word right there. Find me which of the three includes 7, where 7 is actually part of the answer. Josh? The second one. That's your correct answer right there. If you look at this one, it's got that symbol. That means that 7 is not included. It's the boundary. Same with this right here. That doesn't match up with that. So we don't want those two. If it's got a bracket, that means that it includes it. Keep that out. Just put it off to the corner of your desk. How many people remember their domain and range? This should be a fairly easy section on Monday. You already have study guide number 1. Someplace in your notes is 10 questions that we already did. These are the next 14 questions. All of these questions, 11 through 19, all have the same directions. Underline, domain, and range. What letter do we think of when we're looking at the domain? X or Y? Put an X above domain. And what do we do for range? That's the Y's. So these are going to be fairly simple, but I'm going to want you to write them in a very particular way. You could put X, Y, X, Y, X, Y on all of these, just to figure out which ones are the domain and range. This is what I want to see. I want to see a D. I want to see a set symbol. And I want to see them in order. What's the lowest X that you see there? -5. What's the next one? -1, 2, 3. So what you might want to do is cross them out as you write them down. That was -5. Then we had a -1. Then we had a 2. Then we had a 3. So put them in order from least to greatest. Don't repeat it. If you see another -5 or another -1, you don't write it down again. Just write it down once. What is the range then? If I'm starting from lowest to highest?
0.
0. 2. Don't duplicate. If you see another 2, you don't need to write it down. And then what? 6. So there was a 0. There were 2 2s, but I don't have to write it twice. Just write it once, and then there was a 6. Huh? I won't take off, but you don't need to. I will take off if you don't have it from lowest to greatest. We're trying to make things a little more efficient and particular as we move into taking geometry next year. All of this will make sense when we get there. So tell me what I should be writing for my domain for this one. -1, 2, 4. Range. What's the lowest range? -2. Then what? 0. Then 3. Are these pretty easy? We're just looking at notation. But I'm going to be particular about lowest to greatest. I need domain. I need -2, -1, 0, 1, and 2. So this one, this one, this one. All of the x's. What's the lowest range that we have?
0, 1, 1, 2.
0. There's 2 1s. I only need to write down one of them. There's a 2 and a 4. We're just breaking up our input and output. Put that up here. Above x, put the word input. Above the y, put output. All of these are possible words, notations that might be used in other textbooks, might be used on the SOL. You have to know that they all mean the same thing. Input, x, and domain, all the same. You might see drawings like 14, 15, and 16. This is exactly the same as this. Only it's easier. Because they don't repeat anything. This is your D, this is your R. Input, output. So I'm looking at -6, -1, and 4. Place it in order from least to greatest. We only have one output for the next one. So input, output, domain, range, x, y, all of it means the same. That's great if you've got everything in front of you. What if you've got drawings like this? We can do this a couple different ways. Are these lines continuous? Is there any gaps in there? No, there's no spaces. What that means is that all of the numbers might be considered. Next to domain on a graph, let's write left to right. So we want to be looking across. What do the arrows mean? Darken those in. What do they mean? Does it stop? No. It goes forever. Infinity. So is it always going to keep going that way?
Yes.
Is it always going to keep going that way? So I could write this 2 different ways. I could write it like interval notation. It's going to go from negative infinity to positive infinity. Well, if it includes everything, what set is that called? Is that Z or R? R. So I could write this as an R. Either one of those is okay on the test. R is everything. This doesn't stop. There's no gaps. It includes all of the decimals and fractions in between.
So 18 and 19 would be R2.
Yes. For this one, we could put R. For this one, we could put R. Or I could write it this way. You just got to be ready. If this is multiple choice on an SOL test, you might see either one. Let's make sure, though. Does that keep going?
Yes, sir.
Does that keep going? Yes. How about this? Does that have an arrow?
Yes.
Does that have an arrow? It looks like it's just going down, but it's going down slowly to the left, and this is going down slowly to the right forever. It's doing it slower, but eventually it's going to get to infinity. How about range? If domain is left to right, then what is range going to be? Up, down, right down, up, down. So look at the first one. Is this always going to be going up? Do we have arrows? It's always going to be going up. Does it go down? No, it stops right here. What number does it stop at? -4. Circle, -4. What does that look like? Well, that looks like, in notation, that it starts, oops, bracket, -4, because there's a dot there, it includes it, and then what does it go up to? Infinity, and we put a little parentheses around it. Yep. Yep. So we're going to use interval notation this time around. It starts at -4, it goes up forever. These will never stop. So what do you think range is for this one? Is this always going to be going down? Is this always going to be going up? Put another one of these goofy looking R's. When I draw these, I always put 2 vertical lines and then I make the rest of the R. So that it's different than this. What does this R stand for? Range. What does that R stand for? Real numbers. A little bit different. Tell me what to do for this one. I want to look up, down for range. Where does it start at? Circle that. That's a -2. If it goes this way, does it ever stop? No, there's arrows. Whoops. I gotta do it this way, sorry. We always put the larger number to this side. Since that's negative infinity, we put that to the left. I'm making a lot of mistakes today, I'm sorry. Mr. Gordon? Yes. Can you wait about 5 minutes? Sure. Thank you. Whenever you use infinity, whether it's negative or positive, you always have a parentheses there. This is including this, so we want to bracket there. Stop me if you have a question. This is where people get confused. Domain, you're looking left to right. For range, you're looking up, down. If you have arrows, that means it's continuous. So I know that this is never going to end. So I got infinity. If I'm coming down, then it's going to stop there. That's why I stopped at -4. Put the smaller number first, the bigger number second. That's a really small number. That's a little bit bigger. Last time on your calculators, we pressed this button. Do that right now. Take out your calculator, press this button. This is the most important button you'll use all year long. I equals. If something's there, clear it out. We want a clear area. Put it in our functions. Your job is to match these 5 with these 5 tables. Don't go to the calculator yet. Which one of these looks different? You've got this one, this one, this one, this one, and this one. Which one looks different than all the rest? Take a look at that. How many points are in there? 3. That's it. That only has 3 points. Which table looks exactly like that? Which one? 23. B. You've got 2, 1. 2, 1. You've got 1, -4. You've got 1, -8. Some of these are easy. If you just have a couple points, just look for the exact one that matches up. These you'll have to put in your calculator. Start with that. Put in this right here. How do you put in 3x minus 4 into that button? I need everybody to do that right now, and I'll come around. X key is right here. See that X? Press that. Please put in 3x minus 4 so I can see that you know how to enter this. All right. 3x minus 4. X. You don't need the multiplication. Always there. And then minus 4. Just stay there for a second. You got 3x minus 4. All right. Grab a calculator. No. X. See that X right there? Leave that there. You have 3x minus 4 in somewhere? Okay. All right. And you under the instructions in a second. 3x minus 4. 3x minus 4. If you got 3x minus 4 written down, help out Josh for a second. Table 3x minus 4. 4. All right, now erase that. Now, if you want to look at the graph, just hit the graph button, far right. Does a graph show up? It might not be a great graph, but something should show up if you hit the graph button. We really don't want to look at the graph button right now. What we want to look at is a table. All of these are tables. What does it say in blue right above that button? Table. How do you get to the blue stuff? Hit second, then come back to that one. And you will see a table. Show me the table. Show me what's the table. How do you get to the table for this? Table. Blue. Second. Boom. The table. Second. All right, we got a table. How do you get to your table? How do you get to that? See the blue? Second. That one. Touch table. Touch table. Show me the table. Second.
Again.
Just being
Show me a table. Table. You got a table? Alright, you're looking at your table, right? For which one? You see how it's jumping around? You want to go to table set. Where it says table set blue. We want it to start normally at 0. 0, and I want my table to go not by 5s, I want it to go by 1. That. Now it's a little more normal. I can bump up and down just through all the numbers. I'll do it in just a second. You got your table. If you want to move around your table, you look for the ones you need. You got your table. How do you get to Once you get to a table, you can use your arrows to move up and down. Use this and this to see the numbers you want. Which one corresponds to what you see down here? Which one is A? 22? That one goes with that one. What goes with C?
21.
21. What goes with D? 24. And obviously E has to go with. If you are putting this into your calculator, this is how it should look. You should have the equal sign, parentheses, 2, with a slash, the 3, then the X, then the minus 3. Always put the fractions in parentheses. Those keys are going to be really useful the rest of the year. You can create a graph with it. You can enter a bunch of functions at the same time, see all the graphs at once. You can see all the tables at once if you want to. I think it's better to look at them one at a time. This is study guide 2. You had a study guide 1 that had 10 questions on. You should look at both of these before you take your mini test on Monday. Fred, they need you down in the satellite office.